Welcome back to video lecture series on strength of materials, and today we will understand another very important topic of center of gravity and moment of inertia lecture series. And as you can see on the screen, today's topic is theorem of parallel axes. Now this is really very important topic, so let's begin. Consider an area. You have this plane body whose area is A. Okay, let's pass through an axis through the center of gravity. Let this be the center of gravity, and this line is passing through the center of gravity, and let us draw another line parallel to this one. Okay, let's call this as OA. Okay, now if the moment of inertia of this area A about this axis passing through G, okay, is IG. Okay, about this axis the moment of inertia is IG, and the distance between these two parallel lines is something h. Then, according to the theorem of parallel axes, moment of inertia about OA, which is parallel to the axis passing through G, right? Then moment of inertia with respect to OA is equal to moment of inertia with respect to the line passing through center of gravity, that is IG, plus AH square. This is the theorem of parallel axes. What it is saying, I draw two lines. One line is passing through the center of gravity, and the moment of inertia of this area A about the center of gravity is IG. Okay, and I draw another line parallel to this line which is passing through G, right? And the distance between them is h. Then moment of inertia about OA is IG plus AH square, right? This square. This is the theorem of parallel axes, and I can say a statement according to the theorem of parallel axes, moment of inertia about an axis which is parallel to an axis passing through the center of gravity is moment of inertia about the axis passing through the center of gravity plus area of the body multiplied by distance between the two axes square, right? This is the theorem of parallel axes. I can also put this in another way. Let this be an area. Let us draw two lines. This is the center of gravity, okay, or the centroid of this area. Okay, this is the area. Okay, all of this, its area is A, and I draw two lines passing through the center of gravity, right? Let this be x-axis and let this be y-axis, but x-axis and y-axis are passing through this centroid G. Now I draw another set of lines here and here. Okay, let this be O, this be A, and this be B. Okay, now let the distance between this x-axis, which is of course passing through the center of gravity, and OA is h, and let the distance between this y-axis and OB be k. Okay, but keep in mind OA is parallel to this x-axis. Let me call it this as xx. OA is parallel to x-axis, and OB, this is parallel to this y-axis. Okay, yy. This line and this line are parallel, and this line and this line are parallel. Then I can apply the theorem of parallel axes. Then moment of inertia, which is denoted by I about OA, is equal to moment of inertia about this x-axis, right? Because it is passing through G, right? X-axis or passing through G plus area multiplied by distance between the two parallel axes, which is h square, right? I can also apply theorem of parallel axes on OB, like moment of inertia about OB is equal to moment of inertia about y, right? Because this is theorem of parallel axes. We will talk about parallel axes, OB and Y axis, because they are parallel. We will also talk OA and X axis because they are parallel. We will not talk about OB, this line, and X axis, right, because they are not parallel. This is the theorem of parallel axes. We will only talk about two parallel axes separated by a certain distance. Anyways, moment of inertia of this area about OB is IOB, which is equal to moment of inertia about y-axis, right? Why? Because this y-axis passing through the centroid or center of gravity of this area plus A, and what is the distance between the two axes? K. So K square. Now I can also prove it. Now let this be an area, okay? Let this be a strip. Okay, right now we are trying to prove the theorem of parallel axes, right? We are trying to prove it. Proof. Now I consider a strip, okay, in this area. Let its area be dA, okay, because this is a small strip and the total area is A, okay. The total area is A. Let us draw an axis passing through center of gravity. This is center of gravity, okay. Now let me draw an axis. We draw this line, let this be OA, and let this axis passing through this be XX, okay. Keep in mind OA is parallel to x-axis, XX. Now let the distance between them be h, okay, and let the distance of this area, small area dA, from the center of gravity be y, okay. Now let's find the moment of inertia of this area dA about the OA, okay. Let me call this as DIOA. Basically it is IOA, right? Moment of inertia of DA with respect to OA is IOA, but because this is DA area, so I write here DIA, okay. It is equals, we know what is moment of inertia. Moment of inertia is area multiplied by perpendicular distance square, right? So area is dA and the perpendicular distance between dA and OA is what? Y plus h, right? Because from here to here is y and here to here is h, so the total distance between dA and OA is y plus h, y plus h square, right? Square. Now this is the formula a plus b whole square. When we expand it, dA will stay as it is. This is a square, y square plus 2ab 2yh plus b square, which is h square, right? Now let us distribute dA everywhere. This is y square dA plus 2yh dA plus h square dA DIOA, right? This is the moment of inertia of this dA element with respect to the OA. Now when we integrate this, okay, when we integrate all of this will give us the moment of inertia of whole area with respect to the OA, right? Because integrate will do what? Integrate will convert this dA into A. Then this will be y square A. This is A multiplied by y square, right? You can see the integration will affect only dA. It is going to convert them into A area. When it is going to convert them into area, because now the area is whole, right? The whole area will be included after the integration. That's why the integration of this equation is going to be the moment of inertia of whole area about OA, okay. So let me erase this. Now let's integrate it. Now what will be the integration of this? Now this integral and d term will cut. We will get I OA is equal to, now integration of y square dA is y square a, right? This is going to be y square a plus 2y h 2yh, here is dA, it is going to be converted into a plus, then it is h square dA which will be converted into h square a, right? This is h square a, right? Now if I rearrange this, this is going to be a y square plus a h square plus, let me rearrange this term, 2h ay, okay? Now a y square, see, a y square, what is a y square? A y square is the moment of inertia of the whole area A about this x axis which is passing through the center of gravity, right? Because moment of inertia is area multiplied by perpendicular distance. Area is A and the distance between them is y, so it is going to be the moment of inertia of the whole area with respect to the center of gravity, right? So I will denote this term with Ig, okay? Ig plus, this is ah square as it is. Now look at this term very carefully, this thing, this is a multiplied by y. What is ay? A multiplied by y, right? A multiplied by y is the moment of this whole area about what? But if you look carefully, the moment of an area about its own axis is area multiplied by distance, right? Distance from the center of gravity and the axis about which we are trying to find the moment, right? But here the term is y, right? Means this is the center of gravity and we have to find the distance of axis passing through center of gravity, but this, that is 0 because the distance of the axis passing through center of gravity and the axis is 0, right? So this whole term is going to be 0 because ay is 0, so this will be 0. So what we are left with? We are left with only this. So let me write here, I OA is equal to Ig plus AH square. This is the theorem of parallel axis, okay? So we have proved the theorem of parallel axis. And that's it for today. If you want to download the PDF of this video lecture, please look in the description or the comments, you'll find the PDF there. You can download this. And also if you have any doubts about this class, please ask me in the comments. And also if you need solutions of any problem and you are finding difficulty in solving your problems, please contact me. I can also help in solving your problems. And also if you need tutoring in strength of materials, mechanics of materials, statics, please contact me. I also offer one-on-one live tutoring in strength of materials. And that's it for today. See you in the next class. Thank you.